When you look at a railway, what do you actually see? Is it just steel and stone? Or is there something more going on? It's really a philosophy of perfection brought to life. It's an entire system built on one single, unwavering idea, and that is the hidden art of the perfect path.
To really get what makes a railway special, you have to think about what it's not. I mean, take a road. Its job is pretty simple, right? It just has to sit there. It stands still. A railway, on the other hand, well, it never stops moving. It's a system that's designed for constant, relentless motion. And that single difference, it changes absolutely everything.
So that brings up a really interesting question, doesn't it? How does a simple path, just a static line on the ground, learn to become a railway? What lessons does it have to learn to handle such incredible demands? Well, that's the story we're going to explore. Okay, so the very first lesson is all about the path itself. Before a single piece of track ever gets laid down, the railway has to understand just how serious its job is. This is the railway's first big realization. For something that carries massive objects at incredible speeds, there is just zero room for error. A tiny curve, a small imperfection that you wouldn't even notice on a road, on a railway, that becomes a huge point of failure. The path has to be perfect, right from the very start. And because of that, engineers don't just, walk the land, they interrogate it. They use drones to create this perfect map from the sky. They have machines that listen to the soil, checking its density and stability, and they use lasers to measure the Earth itself, making sure that path is absolutely true. Now here's the crucial part. A building, it might be built with a tolerance of a few centimeters, and that's fine. But a high-speed railway, it demands precision down to the millimeter. And this isn't just about being neat and tidy. It is the fundamental layer of safety for a system that is always in motion.
All right, let's move on to the next lesson. Once the perfect path is chosen, the ground itself has to be taught a whole new kind of strength.
And this is a really critical distinction. A building's foundation, it just supports a static load, a weight that doesn't move. But a railway foundation has to deal with a dynamic force, the constant, punishing vibration of a train passing over it again and again, thousands of times.
So you need a totally different approach. The soil isn't just dug up, it's cured. It's hardened with things like lime and cement. Then, these strong synthetic fabrics are laid down, almost like a kind of armor for the earth. And only then is the bed built up, layer by disciplined layer.
You see, the foundation of a railway isn't some passive block of concrete. It's an active, engineered system. It's designed specifically to absorb and dissipate the incredible energy of a moving train, day in and day out, without fail. So the ground is prepared, and now our railway learns its most visible lesson: how to build a spine that is absolutely, completely unbending.
The classic picture of a railway, right? You've got gravel, we call it ballast, spread out between wooden sleepers. Now, that system was flexible. It was forgiving. It could handle little shifts, and it was easy to adjust. But for the speeds we have today, forgiving just isn't good enough.
The entire philosophy had to change. The goal wasn't to build a system you could easily repair anymore. The goal was to build a system that just wouldn't fail. It needed a level of stability that loose stones could never, ever provide.
And the answer was this: a single, continuous concrete slab, a solid spine. The rails are fixed directly onto it. There's no shifting, no wiggling, no give, just pure, unshakable stability.
So why go to all this trouble? Because that concrete spine is what makes this possible. Traveling at 300 kilometers per hour, safely and quietly, you can only do that on a path that is basically perfect, a path that does not move.
But the railway's education isn't done yet. The final lesson is maybe the most profound of all. The physical structure has to be given a brain. It needs to become an intelligent, living system. I mean, a perfect path is a fantastic start, but it's still just a passive object. To guarantee ultimate reliability, the railway had to learn how to monitor itself, how to communicate, how to become aware.
And this is its nervous system, the part you don't see. Power lines run alongside it like veins, carrying life. Signal systems act as a language, talking directly to the trains. Thousands of tiny sensors act like nerve endings, feeling for the slightest vibration or change in temperature. And all of that data flows back to a central computer, the brain, that's watching everything constantly.
And at this point, the transformation is complete. It's no longer just a static piece of construction. It's a responsive, intelligent entity that can sense problems before they even happen and manage the constant flow of motion across its entire system.
So when we talk about the future, things like robotic track layers or even self-healing concrete, it's not science fiction. It's really just the next logical step in this relentless quest for a perfect, self-aware system.
So why is a railway built so differently from a road? Here's its answer. Its job isn't just to be a surface to travel on. Its real job is to carry trust. Every millimeter of precision, every layer in that foundation, every single sensor, it's all there to uphold a promise of speed and, most importantly, safety.
And that's really the ultimate takeaway here. The strength of a railway isn't found in its steel or its concrete. Its success, its genius, lies in its absolute refusal to deviate from that perfect path.